in the IT field, and out of that, for me, so 8 years was mostly I was working in this machine learning or Gen AI, or deep learning in these area. My skill set from the past 8 years. Um, So basically, I will deal with the most of the times I will deal with the NLP problems and computer vision problems, which is we are going to solve by using the image based or video based, those kind of problems, which I have been handled most of the times. So in the initial stages, I worked with the data science related machine learning area problems, something like you get the a numbered related or else a structured data, maybe something like however we are seeing the Excel files, right? So those kind of data or else some JSON files, those kind of data we'll get, and then we'll do the some required conversions, whatever the needed by the algorithm requirement purpose. So those kind of techniques we'll generally use, and then we'll develop the applications. So that's that kind of problems which I haven't worked till now. So yeah, that's about me.
Yeah, that's good to hear, Nehru. Thanks for introduction.
Yeah, maybe if you give your backgrounds also, that will be helpful for me in the demo point of view, or else to make more understanding point of view to you guys.
Yeah, maybe I can start. Yeah. So I'm in this IT industry from past 17 years, Nehru, but totally into functional areas. I was initially started as a business analyst, then became a project manager and a program manager, completely into from the functional side. I was in South Africa and US and back to India now. But because of this competence, which is happening currently in the market, I try to compete with the market, and I would like to upskill myself so that at least I can survive for next 10 years. So the traditional way of style is not working out anymore. So yeah, that's where I'm trying to learn this data science and upskill myself.
Okay. So Deepak, do you have any coding background?
Like my education is a technical background, but
Okay.
initial maybe 1 or 2 years, I did some basic Java core Java programming, and I did
Okay.
some automation, framework, created automation frameworks also by using Selenium JavaScript.
Okay.
But yeah, not really hands-on from past 10 years actually.
Okay. Okay. Yeah. Gayatri.
I so I'm 8 years experienced. I've worked on internal tool of my company.
Okay.
So like I've worked on many scripting languages like PowerShell, Groovy, Bash. So currently I'm into development, testing, and also the maintenance of my tool. So
Okay.
I'm doing end to end in the customer requirement deploy.
It's a tool developed based upon any coding language.
Yeah, so I have idea on I'm currently working on PowerShell, Bash.
Okay. Annapurna.
Basic like development knowledge, like it can be any language.
Okay.
Basic
Okay. Okay. Got it.
knowledge I have.
Okay. Annapurna.
Yeah, hi. Basically, I'm from medical field, so this is new to me. So
Mm-hmm.
this is my first class. So
Yeah.
actually, yeah.
So, what's your goal by this learning of this course, Annapurna? In that case, if you're from the medical background, you're going
So,
to, yeah.
in market, like for my whatever technology I have knowledge on and whatever tool I have knowledge on, I couldn't find any openings. So I want to upskill my knowledge so I could find good jobs in the market. So that's the main reason I'm doing this.
Sorry, Annapurna, you're continuing. Sorry, Annapurna.
Yeah. I want to shift I want to work in this software. So I want to do this Python with data science and all.
Yeah, got it. Maybe why I ask is
Yeah.
maybe in the medical domain you want to implement this, or else what's the maybe your ideology? So that's the reason my question is for. because you should. So you are willing to learn the coding language of Python, or else do you have any past history of the learning of any coding language, Annapurna?
No, I don't have any past history of
Okay,
learning.
okay.
Yeah, but
Yeah, because the ask is for maybe the domain side, each domain. These applications was developing either AML or Gen AI, whatever the naming is, the people is calling out. Okay, so the new technologies or else new advancements where we have to learn, because then only we can survive in that particular industry. So that's the reason. Okay, so I'm jumping into the demo session. Okay, is my screen is visible?
No, no,
It's not visible.
not yet. I can
Yes,
only see the
it is
participant.
visible.
So are you able to see a PPT which is about the machine learning and deep learning
Yes,
something?
I can. Yes, I
Okay,
can.
okay.
And before jumping in there, I have a quick question here.
Yeah, please.
So I just want to understand, like data science and AI, whatever we call. So normally in the traditional way, we get a problem statement from the client or a business requirement. So then we
If
start the
possible,
SDLC
will you please
process.
increase the volume of your machine? I was betting a
Okay,
bit low voice.
is
Yeah.
it better now?
Yeah. Okay. If
Okay.
possible, raise the volume. If otherwise, I will try.
Okay.
Yeah.
Okay, fine. So in the normal traditional way, so we get a problem statement or a business requirement from the client,
Right.
and we start working on the SDLC process, and we develop the product and we deliver it.
Hmm.
Right. So, but now the data science, as you said, where do we use exactly? What is the problem statement behind it? And just want to understand, why do we
Okay.
use data science and where do we use it?
Okay. I'll give you an example. Maybe suppose maybe one of the application, maybe if you're seeing, right, suppose there is a factory environment, assume. Okay. So in the factory environment, they were prepared a product, assume. Okay. The product should go with a quality check, right? When we are going to deliver before to the customer, so or else before to our client to deliver the product. Okay. We have to verify that is the everything is properly, or else is everything is good condition. We have to verify that the product condition side. So most of the factories, what they will do, so a manual inspection will keep there. Okay. So the manual inspection will verify the product is everything good or not. So that's how generally the process will happen. So in place of that, assume, okay, if I keep a computer or else a camera there, okay, the camera will capture the images of that product, and then it validate the product is good or not, and then it will be delivered to the client, the end user, right? So here what we did, we automated the manual inspection, because the manual inspection will have sometimes there is a chance of failures or else a fault tolerance you will have. Compared to that, machine inspection, the fault tolerance will be much less compared to that. And we are automating that work. Human might take a time of a inspection time, maybe a bit more compared to the machine, right? So these things you are replacing. And I'm giving another example. Yeah. Have you heard about the ServiceNow or something like ticketing systems of our,
Yes, I have
right?
used it as well. Yeah.
So in ServiceNow, generally you'll raise the tickets, right? Suppose if you're facing any issues in your work area, something like you might have some laptop issues. I'm just giving some
Yeah,
IT help desk side.
got it.
So I'm facing a OS side issues, or some Wi-Fi issues, or drivers issues, sound issue, laptop, anything, any kind of issues they're mentioning there, right? So then what will happen? The regular process I'm saying, okay. So there would be a person, or else there would be a team. They will read your issue, okay, and based upon the description of that issue what have been provided. They will assign to a particular assignment group. Okay. In that assignment group, the people will work on that and they will provide the root cause, or else they will provide the solution. Assume that was the process. Maybe if you raise a ticket, assume it might take a 24 hours or a 2 days process to complete your issue to resolve, right? But in place of that, if I create a chatbot to you, okay? So what will happen? So you will rise, or else you will provide your issue description there, okay? Based upon the past history, how the ticketing team has been solved that issue, okay? So it knows the how they solve. Okay, we trained our a machine learning or else a deep learning application in that point. Okay, and my algorithm will know what solution will work based upon your issue description, because based upon the past history how they resolved, right? So my algorithm will provide a solution to you, right? So that solution you will implement in your side as an end user, the suggestions, whatever you got from the algorithm. Even though you are not able to complete, or else you are not able to solve your issue, right? It will create a ticket based upon your feedback, and then the particular team will resolve the ticket. So what is happening here in this whole flow? You are reducing the time to resolve your issues, right? And efficiently you are getting the response and usage of the human work here. What I'm trying to say here, so instead of earlier, there might be a 20 people of the team. Maybe because of this reason, you are automated this work, right? So you can reduce the size of the people, because automation will helps the reduce the efforts, right? So that kind of thing you are able to do here. Is
Okay.
answered your question?
Yes, definitely, Nehru. Thanks.
Yeah.
Thanks for the explanation.
Any questions? Any other? Gayatri, Annapurna? If no, I will jump to
As of
the.
now, no. As of now.
Okay. Okay. Maybe is this the first time you are hearing about the AI, or else the data science? Is it first time, or else do you have any idea in your mind what is AI, something like that? Maybe before going into that, right, I will show you a picture. Okay, then you will get the understanding. Okay. Are you able to see the picture here in the PPT?
Yes.
Right. So artificial intelligence, the people is calling is a type is a first type, you can say, or else is the whole whatever the machine learning or deep learning people will call. So these all come under artificial intelligence only, under the umbrella of the artificial intelligence. Okay. So under the artificial intelligence, there is a machine learning is one module. Under that, deep learning is another module. In the deep learning, you will have the NLP and computer vision. These are the other modules. Even the Gen AI also will come under the deep learning only. Okay. The generative AI part. So we are going to cover the machine learning in this course content. Okay. Not the deep learning, not the any Gen AI, not those areas. Okay. The machine learning part we are going to cover. Okay. So basically, the layman terms wise, or else the to understanding our purpose, right? What is AI? If somebody ask, right? So in the layman term, what we will say, so mimicking the human brain by automate the task by using the machines. That's what generally simply we can say. So by doing that, you are able to replacing the humans with machines. So that's the use of this artificial intelligence. So what we are doing here, it refers to the simulation of the human intelligence in machines that are programmed to think and mimic the human actions that you are doing. So AI encompasses a broad range of techniques, right? and technologies, something including a machine learning or natural language processing, computer vision, or robotics, whatever. So these all are involved with the AI. AI involved these all the areas, because whatever you are seeing, the robots, right, in nowadays, so those all are, it has the involvement of the robotics and as well as the AI in that. So these systems can analyze the data, learn from it, and make the decisions or predictions based on the informations they have been processed. Why I'm saying based upon the information what they have been processed, because other information which you do not provide it to that uh, 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 or else to that application, right? It won't aware of that area. You may not get the response, because you may not get the proper outcome in that area from your application. So AI applications in various fields such as healthcare, finance, transportation, education, and many other areas. Okay, now, whatever nowadays we have in all areas, we have the AI applications. So yeah. So if you ask me why we need AI, okay, AI has a potential to address the complex challenge and improve the efficiency, to drive into the innovation area, okay, and enhance various aspects of our lives, making it an essential technology for the present and the future. Similarly, if you take machine learning, it's like what is machine learning? If you ask me, okay, it's like teaching a computer to do something, okay, by showing it lot of examples rather than giving it to the specific instructions. So imagine you have a friend who wants to learn how to recognize different types of fruits. Instead of telling your friend the exact feature of each fruit, like color, shape, etc., right? You show them many different fruits and tell them what each one is. Over time, your friend learns to recognize fruits on their own by seeing lots of examples. In the same way, with machine learning, we feed computer lots of examples of something we want it to learn, like picture of cats and dogs. The computer then learns from these examples and gets better at recognizing cats and dogs on its own. Later, when we show it a new picture, right, it can tell us whether it's a cat or dog based upon what it learned from the examples. Okay. So machine learning is all about teaching computers to learn from examples. Similarly, deep learning is also like teaching a computer. So see find the difference between the machine learning and deep learning here. Okay. Deep learning is like teaching a computer to think and understanding in a way that is similar to the how humans do. Okay, but using very simplified model of the brain. Okay, so take the same example. Imagine you want to teach a child how to recognize different animals. Okay, you start by showing the pictures of the animals and telling them what each one is. Okay, the child sees more and more examples. They start to understand the differences between the animals and can recognize them on their own. So in deep learning, we do something similar with computers. So we feed them lots of examples like picture of animals, and computer learns to recognize patterns in those examples. But instead of telling the computer explicitly what each pattern means, we let it figure that out on its own through trial and error. So deep learning uses simplified model of the brain called a neural network. So this network is made up of layers of interconnected neurons. Just like the brain has interconnected cells, each layer of neurons learns to recognize different features in the example we show. So have you guys understand the difference between the what is ML, what is DL? Hello.
So it's
DL, what is the backend language? How is able to read in with that
So what
with
I'm
that
trying to
machine?
explain here is, right, so in machine learning, you are giving example data and even you are providing the what it is, you're just giving the as a feature as an input in the machine learning. Okay. In the deep learning, you don't have to explicitly provide the features as an input. Okay. You can provide directly the images or else whatever the you have the information. So it will try to recognize the patterns in it. Okay. And it will try to recognize the any features. It will extract the features automatically. You don't have to do any explicitly like that. Okay. And then, so it will detects the patterns, right? It will, instead of telling to the computer, right, this pattern is this pattern is this, instead of telling that, based upon the image you provided, the logic or else the pattern or else the human neurons or else the neurons or cells, whatever in the layers, that will decide that will come under which animal category, those things will happen. So the difference here is you don't have to do any explicitly things. Okay, explicitly you don't have to do what is the feature, also what is the pattern in that in the deep learning, but instead in machine learning you have to give all the features as input, otherwise it cannot able to recognize those things. Is it clear?
Yes. So,
Let me go into the next step. Okay.
actually, I have one doubt. Like they said that the backend language of AI is black box. So is it like
AI algorithm, right? Okay, algorithm, some of the algorithms, we'll call it as a black box. The reason why the prediction is going in that way, or else why we are getting this kind of outcome, you cannot classify or also cannot showcase with the algorithm. Okay, but you can understand by using the examples or else by understanding the patterns, how the algorithm is taking. With that help, by the layer level, if you visualize the data, then why it is taking that kind of decision, you can try to understand. Okay. So now you have the few tools also, something like Shapely, some other tools also. So those will help you. Why my algorithm doing that kind of predictions, those kind of tools also is there in the initial days, or else even now also for some algorithms you cannot know why the prediction is like this. You cannot answer for that because what's the back end, why it is treated like that, we cannot say, because the pattern what it is understood, right? So you have to debug layer by layer, then you will get the understanding. So straightforward directly you cannot say why it took as a that decision. So because of that reason, we'll call few algorithms as a black box. So am I answered your question?
yes?
Okay.
one more quick question, Nehru.
Yeah,
So
please.
from the previous slide, you said you'll be covering only the machine learning, right?
Right.
Not the deep learning and the NLP.
Right, right.
So it only covers the machine learning, so we don't
The
understand that.
course what we are taking, it will cover only the machine learning. Okay, but machine learning is the base for everything. Okay, first thing. So If you directly learn the deep learning, you may not understand the concept, or else you may not understand the other things, because whatever the back end for the deep learning algorithms will cover in the machine learning only. So machine learning is based for everything. So if you understand the machine learning, so then it is easy to digest the deep learning concepts. So if you are interested, then we can take about the deep learning, because deep learning will have again computer vision and NLP, both the concepts will be there. So it will be huge area to cover everything in one area, okay, in machine learning itself. So machine learning, we're going to deal with the data, something like the structured data, semi-structured data we're going to deal with, okay. So images or text data, we'll call it as unstructured data. So deep learning is going to deal with the unstructured data. So our initial focus is about the deal with the structured and semi-structured data. So if we are thorough with the machine learning, and then guys was interested, then we'll go for the deep learning. That's another course if you want to learn about the deep learning, because you cannot cover everything in one area. So that's the reason.
Okay, good.
Yeah. So I guess we covered till here, right? So artificial intelligence, machine learning, and deep learning, till here we covered. And see here. So whatever just now we discussed, right? What is ML, what is DL, okay? So if you observe here, right? So you have the inputs and feature extraction, and then we are doing the learning, and then we are getting the output. But in case of deep learning, so you'll directly provide the inputs. The algorithm itself will do the feature extraction and learning both at one shot. Okay. So then it will provide the output. You don't have to do explicitly any feature extraction in deep learning. But in case of machine learning, you have to do the feature extraction. So basically, a developer has any requirement, right? Most of the time we will invest in the feature extraction only. Most of the time. So suppose simply if you ask, right, to gather the input data, you might spend a 10% of your time in the project time, a 30 to 40% of time in the feature extraction, and building an algorithm in that area you might spend 20% of time. Okay. And remaining 30% you build try to do the model deployment, or else model evaluation. In that area I will spend 30% of time in the whole life cycle. Suppose maybe what I'm trying to say was, now if you go here, what is NLP, right? So under the deep learning concept, right? So so similarly in the earlier example, right, like teaching computers to understand and communicate with human in the way we naturally speak and write. So that will come under as a natural processing. NLP is natural language processing. So imagine you are chatting with your friend on your phone, okay? So you type out messages in your language, okay? And your friend understands what you are saying and responds accordingly. So NLP helps computers to do something similar to that. It allows them to understand human language, whether it's text typed on a screen, or spoken words, or even handwritten. So with NLP, computers can analyze and interpret text to extract meaning, identifying the patterns, and even generate human-like responses. For example, they can help us translate languages, or summarizing a huge documents, okay, answering the questions, even analyze the sentiments in social media posts or so. Okay. So NLP is all about enabling computers to understand and communicate with us in our natural language, making interactions between humans and machines smoother and more natural. So NLP is basically about dealt with the text kind of data, either it's a spoken words or it's a handwritten words or it's a your type text, whatever it would be. Okay. So, but it will extract the text from the given input and it will respond back by understanding the text for the your questions or also for your document. So it will give the response based upon your requirement. Computer vision about the images, either you give an input as an image or video, whatever you will provide. So computer vision will read the image pixel level, okay, and then it will respond to the for the image, whatever you will provide. And NLP is about the text. So both. So that's the reason natural language process is the another module under the deep learning. Computer vision is another module under the deep learning. So computer vision deals with the images. Natural language process will deal with the text data in either of the format. So sometimes what will happen, right? If you provide the image and you want a caption for that image, or else you want the text from that image, so you'll get the text by providing the image. If you provide a text as an input and if you want to create an image, you'll get the outcome as an image. So here it involves both the things, that applications, NLP and computer vision both were involved. So text to image, image to text conversion in that area. Suppose in language translation, if I was speaking in English and if I asked to convert that into the Hindi or some other language, okay, it's a language translation. There, the application is dealt with the NLP. So here you are providing the voice or else spoken words as an input, and that word you will convert into the text, and that text will understand by the machine, and whatever the language you want to convert, and then it will convert into that language. So that kind of applications we will call as a language translation applications. In machine learning, so I will take an example of everybody aware of the BMI, right? Body mass index, BMI data.
Yeah.
Yeah. Suppose an example, right? Machine learning problem dealing with a body mass index, okay, data would involve predicting a person health risk category based upon their BMI, okay, and possibly other relevant features such as age, gender, and lifestyle habits, okay. So suppose if I want to approach this with the machine learning, okay. So how I will approach, okay. So first, what I will do, right? So obtain a data set containing BMI values along with the other relevant features corresponding to the health risk categories, something like the categories. What I'm going to classify is a low risk or medium risk or high risk, based upon the information. These are the three categories I'm going to predict based upon the given input. So the data set should be labeled to to implement a supervised algorithm. Okay, supervised means the label should be what label. Suppose the person height is this much, okay, something like 160 or 165 centimeters the person height, and weight is 75 or 80 kgs, okay, and then what is the age of the person and gender, what kind of food habits he has, or what kind of lifestyle he is. So those kind of information I will collect about a person, and then I will label it as a medium risk or high risk label, okay, and for each person something. So in this way you will collect the information and you will label the each one. So this label part is the going to predict, okay. I'm going to predict based upon the other information, because this low risk, high risk, or medium risk, based upon the experts' knowledge or else experts' understanding, they are giving the labeling at the time of before training a model. Okay, my goal is, okay, Instead of this expert, I want to replace this expert. Okay. Instead of this expert, I will keep my machine learning algorithm that will do the prediction. Okay. In future, if you get the other information, this information is required. Even if my algorithm is built also, that the required input is required, right? The input, either this is the height of the person, this is the weight, and this is the age, and this is the category, gender. Okay. And this is the lifestyle or food habits he was having. That information is required. Only what we are going to do, categorize part. That is the main one, right? Our goal is to categorize. It's a low risk or medium or high risk, the body of the person, right? So then that part, instead of keep by analyzing, the expert analyze these details and initially, and he was giving that category, under which category. So I want to replace that expert position by my algorithm, right? So I'll keep my algorithm in place of that with the past history trained. So then my algorithm will predict based upon these input details. That I will call as a evaluation or else the model testing in that phase. So what will happen, right, in the life cycle initially? So initially you will do the training. Okay. So so what you will call this is, it's a supervised algorithm here. Okay. Because you already labeling the features. So each one, right? You know what it is, the category for each one. So I will train my algorithm. Okay. So my algorithm will going to predict it. So initially you will train that. So, and at the time of, so is the my algorithm is working, is accurate or not to do that. So I have to evaluate my algorithm. So I will take a bunch of data and I will do the predictions and evaluate it. So I know the actual values of that. I know the prediction values of that. Okay. So then I will see, okay, how the algorithm is functioning, because it's a 90% accuracy or else it's a 95 or 75% accuracy. First, I should evaluate. So based upon the performance, if I'm okay with that performance, then I will move that to the testing phase. So I will release that for testing. So then if we are happy with that testing results, then we will do the deployment. So that's how general life cycle. Suppose in place of, in similar way, right? So the same BMI problem. So here in the machine learning, I collected this data, okay, and that data I provided as a feature, as an input to my model. Then I am doing this prediction. So instead of that, right? So suppose if I deal with this as a computer vision problem, assume, okay. So what we would do, we would use the image data related to the body measurements, like image of individuals we will take, okay, along with their corresponding BMI values and health risk categories, okay. Suppose what I'm saying, medium risk is a one category. All the medium risk people will keep in a one folder, assume in our terminology, okay. I'll create a folder of the medium risk. In that, I'll keep all the medium risk people, okay. In another folder, high risk. In another folder, low risk. All those people images I will keep, okay. So then that data set, I will train my image algorithm with that each folder. And then my algorithm in future, if you suppose, if I take a new person image, okay, that new person will come under as a which category? It's a high risk or low risk or medium risk. So let algorithm will decide the features extraction. So here you are not doing any feature extraction. You are just providing the person image as an input. So initially you know the based upon the expert knowledge, right? You know is a high risk or medium risk by seeing the person side, okay. So that kind of thing you are going to do if you are dealing with the same problem with the computer vision. And one more example, I can say spam or email detection in our spam email detection, right? In our emails, right? So imagine you receive a lot of emails every day, okay? But some of them are annoying spam image messages trying to sell you things you don't need you don't need, or even trying to scam you, right? So now think about how you can train a computer to automatically detect these spam emails, so you do not have to waste your time sorting through them manually, okay. So what you will do, to train a spam email detector, right? We gather a large data set of emails, okay. Some of these emails are labeled as a spam, are junk, okay? While other are labeled as a some maybe a right email, okay? Maybe legitimate emails, okay? So feature extraction you will do, okay? Next, we need to identify the feature or characteristics of the emails that can help the distinguish between the spam and right emails, okay? So these feature might include the frequency of certain words or the presence of the suspicious links or attachments or the sender's email address. Those kind of information you will have. So then you will train using the label data set. So you can train the machine learning algorithm or the pattern that different from the spam emails. So then it will try to identify that. So based upon these features as information. So generally this will come under as a natural language process problem, but you can even solve with this kind of problems using the some machine learning techniques also can solve these problems.
Yeah, I have a quick question here.
Yeah, please.
So now, since the course curriculum is only talking about the machine learning, right?
Right.
But the other problems that you already been discussing, these are all like converting the unstructured data to structured data first. Then machine
Right.
learning will come into picture, right?
Right.
So how do we deal with unstructured data with machine learning? Does it really covers, or does market really have that kind of demand, or do they talk about deep learning and NLP techniques or mask
We
for
have
the
the some of
development?
the problems. So generally what we'll have, right? So we'll convert the unstructured data into the structured data. There are a few steps, okay? So that will cover in the machine learning part, okay? If you have the, maybe what I'm trying to say, images, right? If you say, so images, sometimes you'll maybe in pixel level information, even if you take that, you can treat as a structured data, convert it to that. But that cannot solve the actual requirement by treating that unstructured actual data, you convert it to the structured. So actually what I'm trying to say is, so the natural availability of the data, if you are converting it to the unstructured into the structured, it will not solve the problem, okay? And even some text data you can treat with the machine learning, okay? So I will take the some of the one of the problem, I will treat the text data with the machine learning. So then you can try to understand how you can solve the some unstructured data using the machine learning also. I will take the one problem, okay? And so I will try to explain how you will deal that kind of unstructured data, how you will deal with the structured machine learning applications, how you will deal or else how you will solve the problem if you want to solve with the machine learning. But what I'm trying to say was unstructured data should be deal with the unstructured algorithms only. That will be the good, okay? Because what I'm trying to say, natural availability of the data is in unstructured. So the best way is going with the unstructured only. If you convert that into the structured data, then you are going to lose the actual data, actual values or else actual data you are going to lose. You're converting one form into another form you're doing, right? So there should be definitely a loss of the data. Yeah, that's what I'm trying to say. But why I'm giving this explanation if you, for that question is, so I want to give you the what's the whole AI, okay? Because in which area what we are going to, but because might be you're in assumption of, okay, maybe I'm going to cover everything in the machine learning. So that's the reason in whole AI, these are all the sub modules, and these kind of problems is going to deal with in this area, okay? In machine learning, we are going to deal with this only, that I'm going to cover.
Okay, so let's say, for example, we working in a pharmacy industry and or a hospital management system. We're
Right.
trying to analyze all the prescriptions
Hmm.
and convert them, and do the predictive analysis for the future medication, right?
Hmm.
So, which technique we can use? Is only the machine learning can be used, or
Suppose what I'm trying to say, if you have a patient, okay, you have you have all the history of the patient records or something, the what kind of, suppose what I'm trying to say, maybe earlier I took the BMI example. Instead of the BMI example, okay, I can say the person is having the a cancer, okay, assume, okay. So maybe cancer will have the some values of the body. You'll go with the some tests, right? Generally, right? So based upon the test, based upon the some values or high or something was differ from the regular person, right? So because of that reason, you are going to assuming that person might have the a cancer or something like that. So or else something, a BP sugar patient, assume, okay? So what we have to do generally, right? So what are the regular features which is able to separate a BP patient or non-BP patient, assume, okay? Blood pressure patient or non-blood pressure patient, I'm saying. So you will collect the information in a structured format. Suppose here you don't need to validate the other things. So maybe what are the major things would be what's the person age, and if required the gender, okay, and if required in which area he was staying, okay, either of the problem, what I'm saying, those kind of features, and the what is the BP, or else the what's the other values, sugar values, those if required, those values, and is it in high or else low risk or something like that. You can, what I'm trying to say, if your problem you are able to gather the information in this structured way, okay, then you can deal with a machine learning application. Because in all the areas you cannot deal like this. Suppose what I'm saying, in some diagnostics, right? So you have only the diagnostics information, maybe scanning information or some those kind of information. If you have, you don't have all the details of the person or else that kind of information. So then that is a unstructured data. Then you have to deal with a computer vision or some other that kind of information, that kind of application you have to deal with. So based upon the data availability in the industry, you have to go with a machine learning or else a computer deep learning, that will decide. So the availability of data will decide which way you should choose. Is it answered the question?
Yes, definitely. But what's the industry standards? Like, what are they? Because, we are trying to upskills, right? But if we are still learning only the machine learning, will that be helpful, or we have to learn the NLP and the deep learning as well?
Generally, right. So what kind of because everybody will not solve all the areas, right? Generally, nobody will solve all the areas. Suppose I am the person, assume, okay. So initially I worked in the machine learning, later I jumped to the deep learning. So based upon our project we are getting to deal with that, we should learn the things. So suppose initially you got the structured data for one of your project, assume, okay, then machine learning should be fine, okay. But you want to deal with the later on. So if you, for the straight answer is you should learn everything, Deepak. Because if you want to deal with all the problems, if you want to solve all kind of problems in this area, you have to learn all the things. But what I'm trying to say, based upon our project level only, we learn the things. So for some projects in machine learning only, you need to solve the problems, because in some problems you cannot get some images or those kind of information because of the security reasons. In some, suppose what I'm trying to say, uh, suppose a finance details will be there, right? Generally banking domain, right? So if you are going to deal with the banking domain, definitely you should go with the machine learning. There you should not implement most of the areas in deep learning areas, or in a retail industry, or else in that area, right? So there also most of the problems you'll deal with the machine learning only. Suppose a sales problem you are going to deal with, or else so how the sales is happening in this particular season, or else in that area, or else in that. So based upon the problem area, you have to deal with. So suppose if you ask me in healthcare, right? Healthcare, maybe 50-50. I'm saying deep learning will solve the 50% of the problems. Machine learning will solve the 50% of the problems.
Okay, great. Thank
And
you.
if you're building an application with
I'm asking
respect to
so many
a
questions.
conversation or else something, a text analysis or document analysis, those kind of problems, right? Assume. Definitely you cannot deal with that with the machine learning. There you should go with the NLP. Definitely you have to go with the deep learning.
Okay. Okay.
Yeah. So the bottom line is, it's not a straightforward, okay. You can say, okay, only this should be sufficient for your rest of the life. That's not the answer, okay. So the area where we focused, or else the goal, or else the ideology what we are building, okay. What I'm trying to say was, in maybe if my project is required to learn this NLP or else deep learning, we should ready to learn the deep learning or NLP. why I'm saying, right, machine learning is based for everything. Suppose there is some algorithm of gradient descent or else some other uh, smoothing techniques or else data pre-processing techniques, whatever we are dealing in machine learning, that should be common in a computer vision or natural language processing. So the base is common in case of machine learning or computer vision or natural language processing. So if you understand that, right, then that would be make you easy to understand the why the algorithm is functioning in that way. To understand that would be easy. So that's the reason. So my initial course would be the machine learning I'm starting. Okay. So then you can jump to the either to the NLP or computer vision based upon the person to person need basis. Okay. If you want to learn everything, you can try to learn. Yeah, that will be helpful only, but that will take the time consumption as well. Okay. What I'm trying to say was the machine learning will take the time consumption around 2 months approximately, maybe a 15 days vary. Okay. Maximum a 2 months of time if it takes a machine learning course. Okay. NLP again will take the 1.5 month. Computer vision take 1.5 month almost. Okay. Or 1 month. Okay. 1.5 month of the computer vision, 1.5 month of the NLP. So if we took the course of 6 months, right, that's not a feasible, right? To 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 stretch for a 6 months for everyone is not a feasible. So for that reason, split it the because everything you can because some people will feel, right. So based upon their background of work or something, their use cases, they should limit because if you know the machine learning, right, so I can solve my problems with the machine learning. If the people feels like they can stop with the machine learning, if they want, okay, no, I want to use the I have the different kind of problems, maybe I have the unstructured data of the problems, I have to deal with the NLP, then you should learn the NLP and computer vision in the same way. Yeah, if you are going to deal with the images of those kind of data, then you should go with the NLP, so it's computer vision as well. So basically, machine learning or deep learning are super smart assistants that helps us solve problems and make decisions in our everyday lives. Okay. So ML and DL are like helpful friends who learn from examples to make our lives easier and more convenient. Whether it's sorting through emails or recommending movies or even driving us safely to our destinations. So have you guys heard the autonomous driving cars? You know, right?
Yeah.
Nowadays, you are hearing Tesla has the autonomous driving car. Most of them has
Go
the
with Tesla.
autonomous parking also is there. Even the Mahindra cars also auto parking facilities, right? So these all built with respect to the deep learning, actually, or else we can say under the umbrella of AI, we can say. And recommending movies, even if you have the Netflix, right? So based upon your past watch history, it will take into the consideration. Okay, then it will try to recommend you which kind of movies you would like, right? Those kind of suggestions you will get from there. Even if you in Amazon or in Flipkart, if you purchase the something, right, so you'll get some suggestions based upon your purchase history. So these would be, suppose if I purchase a mobile phone, I'll get a recommendation of the mobile accessories or something. Those kind of suggestions you are getting, right? So there, the backend we are using this kind of AI technology is the backend for that. So recommendation is some kind of, there is some other techniques would be there. So for everything, right? So why I'm saying, right? So the recommendations, these most of the things, right? So recommendation will be mostly dealt with structured data most of the times. Okay, the structured data means the past history of the purchase history. Those you'll that history will provide a structured information. The recommendation mostly will go with the unsupervised learning, the recommendation, but the data would be in the structured area. It would be the data. So recommendation, clustering, okay, simply I'm saying, okay, recommendation, clustering, and then bagging and boosting, these kind of, some of them will cover in the machine learning only. If the person was related to the retail industry or else something to this sales area, assume. So for that kind of problems, machine learning would be the sufficient if the person is going to deal with those kind of problems, what I'm trying to say. Yeah. So if you see, right, the real-time use cases, healthcare or finance, in healthcare also, medical image analysis, predictive analytics of the disease, drug discovery, so personalized medicine or treatment recommendation, okay, and finance, fraud detection, credit scoring, and risk assessment, algorithmic trading point of view to the stock market prediction in that way, okay. Retail industry, manufacturing industry, so in the retail, recommender system to product recommendation and customer churn prediction. If the customer is going to leave the our organization as something like that, our services or something like that, so that how you can retain them, what are the strategies you should follow, and manufacturing industry, so how you should do the predictive maintenance or quality control or supply chain optimization, energy consumption optimization point of view. So in the automotive industry also, autonomous vehicle driving, self-driving cars, okay, predictive maintenance of the vehicles, traffic flow optimization, rerouting of the planning of the route maps, okay, driver behavior analysis and safety monitoring. So how the driver is, so driver behavior, so it will alert from the threats, right, based upon the, if the driver was sleeping or if the driver was something like that, okay, it will give the details based upon that. And marketing and advertising, so customer segmentation and tagging, sentiment analysis of the social media, okay, personalized content recommendation, campaign optimization and attribution modeling, so in that area. So basically those kind of all the industries currently we're using these AML techniques there, okay. So in the machine learning advantages, if you ask, we are doing the automation and accuracy. So you are able to identify the insights, why it is the correlation between the data in that kind of the valuable insights you can get from the data what you are providing. So real-time processing, most of the times you will get the real-time outcomes. So yeah, that's it from the demo side. This is the details. Maybe if you have any questions, you can raise the questions. Okay. Before going to the questions, in this machine learning whole course, right? So we're going to deal with the Python is the programming language. Okay. So first few days we'll spend time on the basic. I'm not going to make you as a Python developers here. So whatever is required for our programming language, I will teach you. Okay. So maybe what are the different types of data sets, how you can write the code of the minimal things, I will just teach you in the initial days. And for each category of the problem, each category of the algorithm, I will take a problem and I will try to solve the problems. Based upon solving the problems, you are going to learn. Okay. I'm not going to teach you the everything as a theory. Okay. Maybe a 20% theory, 80% is the implementation I'm going to do. Okay. Suppose in machine learning, there is a classification is there, regression is there. I'm saying the problem categories, okay? Classification, regression, clustering, and then recommendation. So, so some other techniques of the feature engineering or else the EDA. These EDA and feature engineering is common for every problem statement, okay? But for each problem category, I will take a real-time problem, or else I will take a open data set. I will take that. With that help, I will try to solve that in front of you guys. Okay. Then you will try to understand how each algorithm is performing with respect to that data. So that kind of teaching will help everyone as per my understanding. So that's the reason I'm going to in that way teach. So it's a real-time coding in front of you guys, and with respect to the each, I'll take the different types of the problem statements. Yep, that's it. That's it from my side. If any questions, you can raise the questions. Hello, Deepak, Gayatri, Annapurna.
Yeah, I'm good from my side, I'm good. I got what I exactly. I'm gonna get it from the course.
Gayatri, any questions?
I don't have any question.
Okay. Okay then. We can wind up the call. Thanks.
Thanks, Nehru. Thanks for your
Yeah,
time.
thank you. Thank you.
Thank you
Yeah,
so
bye.
much.
Yeah, thank you. Bye.